Welcome to the IT free training video on creating first-generation virtual machines on Hyper-V. This video will look at how to create a first-generation virtual machine and also look at the settings that can be configured on that virtual machine. I will now change to my server running Windows Server and Hyper-V. The Hyper-V role has already been installed and configured on this server. To add a first-generation virtual machine, I will first open Server Manager. Since Hyper-V is installed locally on this server, the Hyper-V option will appear on the left-hand side. Once selected, it will show the local server in the list where I can right-click and then select the option Hyper-V Manager. Once Hyper-V Manager has opened, to create a new virtual machine, I will right-click on the server name on the right-hand side and select New, followed by Virtual Machine, to start the New Virtual Machine wizard. Once I'm past the Welcome screen, on the next screen I will enter in a name for the virtual machine to make it easy for other administrators to know what operating system is running on the virtual machine. Below this, you also have the option to store the virtual machine in a different location. However, in this case, I will not specify an alternate location to store the virtual machine. On the next screen of the wizard, I need to choose which generation of virtual machine that I will use. In this case, I will leave it on the default of Generation 1. Generation 2 offers additional features over Generation 1. However, it requires Windows 8 or Windows Server 2012 as the client operating system. If I now move on to the next screen, on this screen I need to decide how much startup memory the virtual machine will be given. In this case, I will change the default value to 2048. The value will stay at 2048 unless I tick the option below this, Use Dynamic Memory for this virtual machine. This will allow Hyper-V to dynamically change the amount of physical RAM that is allocated to that virtual machine as required. I will look at this option later on, so I will leave this unticked and move on to the next screen of the wizard. On this screen, I need to select which network the virtual machine will be connected to. In this case, I will select the network adapter listed and move on. In later videos, I will look at networking in Hyper-V in more detail. On the next screen, I need to decide which virtual hard disk will be used with the virtual machine. The default option will create a new virtual hard disk. If you had an existing virtual hard disk, you could select it here. In this case, I will leave it on the default option and create a new virtual hard disk to use with this virtual machine and move on to the next screen of the wizard. Here I need to decide how the operating system will be installed. The first option will not make any changes to the virtual machine and require the administrator to make changes later on in order to install the operating system. The next three options configure the virtual machine to install the operating system from the optical drive, floppy disk, or from the network. These three options essentially change the boot order of the virtual machine. In this case, I will leave it on the default option of Install an operating system later and move on to the next screen of the wizard. The last screen of the wizard provides a summary of the options that were chosen in the wizard. Once I press Finish, the first generation virtual machine will be created. The virtual machine will now appear under Virtual Machines in the Hyper-V Manager. In order to configure the virtual machine settings, right-click the virtual machine and select the option Settings. All the settings for the virtual machine are shown here. The first option, Add Hardware, allows the administrator to add additional virtual hardware to the virtual machine. The first hardware you can add is a SCSI controller. The virtual machine can support 2 IDE controllers with 2 devices, making a total of 4. Generally, if you need more virtual hard disks, you would add a SCSI controller. It should be remembered that first-generation virtual hardware cannot boot from a SCSI controller, so you need at least one IDE controller in order to boot the operating system. The next option is Network Adapter. You can add up to 8 virtual network adapters per virtual machine. The network option Legacy Network Adapter allows you to add 4 legacy adapters, making a total of 12 virtual network adapters. The difference between the two network adapters is that the legacy network adapter supports booting from the network. The next option is for a fiber channel adapter. If you are accessing data using a fiber channel, you can use this option to allow the virtual machine to access the storage via fiber channel directly. The last option, Remote FX 3D Video Adapter, is grayed out, as it has not been configured yet on this server. This option allows the 3D hardware in the server to be used to send 3D images to the client. If I select the next option down, BIOS, this allows the boot order of the virtual machine to be configured. Notice that the legacy network adapter is included in the list. If I had chosen to install the operating system from the network during the virtual machine creation wizard, the legacy network adapter would be at the top. In this case, the CD is at the top, which will suit me as I will perform the operating system install using the virtual optical media. The next option down is memory. If I select this option, this will show the memory options for the virtual machine. At the top is the startup RAM, which is currently set to 2048. When the virtual machine starts up, it will be allocated this much RAM. This will stay at that amount unless the tick box below this, Enable Dynamic Memory, is ticked. When this is ticked, notice the options for minimum RAM and maximum RAM below this come into effect. What happens is that Hyper-V is able to increase or decrease the amount of physical RAM that has been allocated to the virtual machine. This is a useful feature if you have a lot of virtual machines that may only rarely use a lot of RAM. If this is the case, using dynamic memory can increase the number of virtual machines that can be used on that server. If you decide to use dynamic RAM, make sure you have enough physical RAM for all the virtual machine requirements. If all virtual machines running on that server ask for additional RAM at the same time, the server could run out of RAM, and the server may start to use virtual memory, slowing down the performance of all the virtual machines that are running on that server. During booting and installing the operating system, the virtual machine may require more RAM than the default 512 megabytes. For this reason, it is a good idea to leave the startup RAM at least at 1 or 2 gigabytes if you are running Windows Server 2012. If you do not have enough RAM to allow a high startup value for all virtual machines, later in the video I will look at how you can use the delay startup option to get around this limitation. You may also consider reducing the amount of maximum RAM. In this case, this server does not have the default amount of 1024 gigabytes of RAM. It is good to have some extra RAM when needed. However, if a program had a serious memory leak, it could potentially, given enough time, use all the available RAM. If the server is never planned to use more than a certain amount, you should set this value to a lower amount. The next option down allows a buffer to be configured for the dynamic memory. Hyper-V will attempt to keep this buffer available for the virtual machine, so when it requests additional RAM, it will be available. The last option is memory weight. This allows the administrator to prioritize how much RAM will be allocated to that virtual machine compared to other virtual machines in the system. This allows the administrator to prioritize memory for servers that are more critical to the company. In this case, I will untick Enable Dynamic Memory and move on to the processor section. At the top, you can configure the number of processors that will be allocated to this virtual machine. A processor in a virtual machine is a single-core CPU. If you increase the number of virtual processors, this will increase the number of cores the virtual machine will be able to access. This is one way to increase the amount of CPU power that a single virtual machine has. The other way is to adjust the settings below this. The top setting, Virtual Machine Reserve percentage, allows a percentage of the CPU to be reserved just for the virtual machine. If you have a virtual machine that is high priority, you may want to reserve a percentage of the CPU just for that virtual machine. If the value is 0, which is the default, no CPU will be reserved for the virtual machine. The next setting, Virtual Machine Limit percentage, defines the maximum amount of CPU that virtual machine can use. If you have a virtual machine that requires a lot of CPU, you may consider reducing this value so it does not cause too many performance problems for the other virtual machines. The last setting, Relative Weight, defines how much CPU this virtual machine will get compared to the others. The weights of each virtual machine are added together. The total sum of all the weights is divided by the number of virtual machines. This number is used to find the relative amount of processing that will be allocated to each virtual machine. If you want to give a particular virtual machine more CPU than the others, increase the amount of the weight value of that particular virtual machine. If I select IDE controller 0, this gives the option to add a virtual hard disk or DVD drive to that IDE controller. Each IDE controller can have 2 devices on it. If I select hard drive, this shows that IDE controller 0 has 1 virtual hard disk connected to it. If I select the controller pull-down, I can change which controller this virtual hard disk is connected to. I can even move it to a SCSI controller if I wish. I can also change the location, which is essentially whether the virtual hard disk is the first or second hard disk, or in the case of SCSI, 0 to 63. Below this, you can see the full file and path that has been used by the virtual hard disk. If I press the Edit button, this will launch the Edit Hard Disk Wizard, which will allow changes to be made to the virtual hard disk. Once past the welcome screen, on the next screen there are a few options. The first option allows the virtual disk to be compacted. When you add and delete files on a virtual hard disk, this can increase the size of that virtual hard disk. Compacting that virtual hard disk will reclaim space in the virtual hard disk, reducing the size of the virtual hard disk. The Convert option allows the virtual hard disk to be converted from one type to another type. For example, a dynamically expanding hard disk could be converted into a fixed-size hard disk. The last option, Expand, allows the virtual hard disk to be expanded. This effectively increases the size of the virtual hard disk. If I cancel out of here, I will next press the Inspect button to get some information about the virtual hard disk. You will notice at the top, the virtual hard disk is listed as a dynamically expanding virtual hard disk. This means the virtual hard disk will expand as required. Below this, you can see that the current size of the virtual hard disk is 4 megabytes. Since no data has been put on the virtual hard disk, the virtual hard disk is still quite small. You can also see the maximum disk size is 127 gigabytes. If I close out of here, you will notice the option for Physical Hard Disk is grayed out. This option allows a virtual machine to have direct access to a physical drive rather than having the data stored in a file. In order to have this occur, the virtual machine must have exclusive access to that drive. In order to do this, the drive must be made offline, so the operating system will not be able to access it. In a later video, I will have a look at how to do this. The next option down is for the virtual optical disk. In a lot of cases, you will use this option to install the operating system. This can be done using a physical drive or an image file stored in ISO format. In this case, I will use an ISO image, so I will need to select the option Image File and then press the Browse button. I have stored an ISO file with Windows Server 2012 R2 on the local drive of this server, so I will browse to it and select it. Once selected, I will press the Apply button to ensure that the ISO is mounted to the virtual optical drive, so I can use it later to install the operating system. If I select the next option down for SCSI controller, you will notice this gives me the option to add a SCSI controller. Unlike the IDE controller, there is only the option for hard drive. Once I press Add, a SCSI hard disk will be created. To create a new virtual disk file, press the New button and start the new virtual hard disk wizard. In later videos, I will go into more detail about creating virtual hard disks, so in this case I will cancel the wizard. In this case, I do not need the extra SCSI hard disk, so I will press the Remove button to remove it. The next section is the network adapter. The top option allows you to choose which virtual switch this virtual machine will be connected to. In later videos, I will look at the networking in virtual machines in more detail. Under this, notice the option for Enable Virtual LAN Identification. This tick box allows VLANs to be used. In this case, I will configure this to 2. On my network, I use VLANs to create separate networks using the one network. You can see that Hyper-V, in contrast to other virtualization solutions, is a very simple process to configure a virtual machine to use a particular VLAN. Under this option is Enable Bandwidth Management. If this option is ticked, you have the ability to define the minimum and maximum bandwidth that virtual machine will be allowed to use. If I select the next option, COM1, this allows a serial port to be configured. You are free to map it to the local computer or a remote computer. Serial ports are not used that much nowadays, so you may never need to use this option unless you are running a very old application in a virtual machine. If I select the floppy drive option, this allows a virtual floppy disk image to be attached to the virtual machine. The image of the floppy disk is stored in a file. With the increased use of USB flash media and other methods to transfer data, you may never need this option, but it is there if you do need it. Under Management, if I select Name, this allows a name and description to be entered in for the virtual machine. To help other administrators, you should enter in meaningful information here. If I select Integrated Services, this shows additional services available to the virtual machine. In order to access these integration services, it needs to be installed or pre-installed in the operating system. I will cover this in more detail in a later video. The next section, Checkpoint File Location, determines where the checkpoint files for the virtual machine will be stored. In some cases, the administrator may want to store these in a different drive from where the virtual machine file is stored. The next section is the Smart Paging File Location. If you use dynamic memory, this may be used. When a virtual machine starts up, it may require additional RAM. If this is not available, the Smart Paging file may be used. This is used as virtual memory until the machine is started up and it can be released. This is only temporary and will be deleted after the virtual machine has started. The most likely time this will occur is when a virtual machine needs to be restarted and all the physical RAM is in use. In order to ensure the virtual machine starts up, Smart Paging will be used. For this reason, an administrator may choose to store this Smart Paging file on fast hardware like a solid-state drive. The next option down is the Automatic Start action. When the server is restarted, these settings will determine how and if the virtual machine will start up. The default option, Automatically Start if it was running when the service stopped, will put the virtual machine in the same state as it was when the server was shut down. So if a virtual machine was running, it will be started up. If the virtual machine was not running, it will be left in a stopped condition. The option above this, Nothing, will essentially leave the virtual machine in an off state when the server starts up. The last option, Always Start this virtual machine automatically, will start the virtual machine every time the server starts up. Which option you choose depends on what the administrator is trying to achieve. The option below this, Startup Delay, will create a delay before the virtual machine is started. This is a very useful option. For example, you may want to ensure that your domain controller starts up before the other virtual machines. To do this, you would put a delay on the virtual machines to give the domain controller time to start up. Also, if you have critical applications running on particular virtual machines, you can have no delay on these virtual machines and put delays on the less critical virtual machines. The last section is Automatic Stop action. This determines what happens to the virtual machine when the physical computer running it is shut down. The default option, Save the Virtual Machine State, will save the virtual machine current state, so when the virtual machine is started again, it will carry on from where it left off. The next option will turn off the virtual machine. This has the same effect as switching off the power, so in most cases you would not use this option. The last option will attempt to shut down the virtual machine. This essentially runs a script on the operating system that tells it to shut down. This covers all the options for the virtual machine. I will now exit out of here and go back to the Hyper-V Manager. If I select the virtual machine, you will notice at the bottom right-hand corner all the options for the virtual machine. These allow access to the options and settings in the virtual machine. In this case, I will press Start to start up the virtual machine. You will notice that you can see an image of the virtual machine screen at the bottom. This is a bit hard to see, but if I double-click the virtual machine, this will open a larger window. From here, I am able to use the virtual machine like a physical computer. This covers how to create a first-generation virtual machine and also the settings available in first-generation virtual machines. In the next video, I will look at how to create second-generation virtual machines. I hope to see you in that video or other videos from us. Until then, thanks for watching.